And thank you so much to the organizers for contacting me and giving me this chance to present my work of all my PhD in this Stringy talks. So the first thing I want to do, just to put everyone at equal footing, is to explain what the dark bubble model proposal is. And basically, this proposal says that one can induce a four-dimensional expanding cosmology equipped with a positive cosmological constant, living on top of the boundary of a five-dimensional bubble that is mediating the decay between two different non-supersymmetric anti-de Sitter vacua. Okay, not only that, you cannot only induce a positive cosmological constant on the boundary of the bubble, but you can also decorate this cosmology with familiar energy densities, and that has to do with whatever you put into the bulk, into the non-supersymmetric ADS vacua. I will elaborate more on this during the talk, but as always, it's always good to have a nice motivation of why we want to do all of these things. So basically, like 20 years ago, we observed that the universe is expanding in an accelerated manner. We have a string theory, and what we want to do is to extract models from string theory that resemble more or less what we see. Then the point is that after all of this time, yes, plenty of work has been done, we make progress, but still getting a positive cosmological constant in Fourier from string theory is really, really hard. There are problems like breaking supersymmetry, moduli stabilization, and scale separation. At the same time, well, this motivated a little bit the Swampland program. What kind of properties these kind of theories, quantum field theories of gravity at low energy regime, should have such that they can be derived or not from UV complete theories. And then in the Swampland, we have plenty of conjectures that they may look like severe restrictions. But then the point is can we exploit these restrictions? Can we use some of the conjectures in our advantage? And that is where more or less this model does, because it's based on the idea that non-supersymmetric anti-de Sitter vacua that are supported by flux should decay by brane nucleation. So let me just start constructing this model directly from type 2B, and this is something that I did together with my supervisor and a collaborator in Finland last year. So I will not go too much into the detail, but just to say that we have type 2B supergravity, ambient space there, and then a stack of D3 branes that are sitting there with some properties such that they are unstable, okay? For the ones that may know, is like the dual field theory, there is non-temperature, and then there is a really high chemical potential. So the point is that we know what the Newton's constant is related to the Planck length in 10D. And then we know that close to that stack of D3 branes, the near horizon geometry looks like ADS5 crosses 5. Then we know how to relate the Newton's constant in 5D to the Planck length or to the Newton's constant in 10D, and it's just by dividing by the volume of the compact dimensions. Ooh. I see 2 questions in the chat. Yeah, is everybody listening? Does everybody hear me?
I can hear you, yes.
Okay. Yeah, I mean, I saw these questions here, and maybe, I mean, I do not trust my earphones, so maybe that was the reason. Okay, so we have learned that. We know how to relate the Newton's constant in 5D to the Newton's constant in 10D, nothing new. And then we also know that, well, we have an ADCFT dictionary that relates the scale, the curvature scale of those branes to the number of branes that we have into the stack. Then if we use the relation, we can re-express the Newton's constant depending on the number of branes, and also the Newton's constant in 10D to the number of branes we have into the game. So that gives us already a hierarchy that we can rearrange in terms of the number of branes we have into the game as this. This is nothing new. This is more or less things that you can do with the technology you have at hand. And then we found what the scale hierarchy should be down to 5D. Now the point that, okay, we have that stack of branes. If we look, for example, at the near horizon limit geometry, this look as ADS crosses 5, that we can basically relabel, rewrite as an anti-de Sitter rising non-true black hole that is unstable, and the instability would cause the nucleation of of a brain, a D3 brain, will escape from the horizon, and then will start expanding, dividing the non-supersymmetric vacua into two pieces, what we call the inside and the outside. And the inside already has decreased the flux value into some units. So now we have this construction, and then one question that could arise is like, okay, if we have such a brain separated, mediating between two different vacua, what energy momentum tensor the brain should have such that the whole space remains as a solution to the Einstein equations? This is given by the Israel junction conditions, and there are two of them given by the following. The first line that you see there says that the induced metric on top of the brain should be the same if you approach from the left, from the left of the brain or from the right of the brain. So basically, you have exactly the same induced geometry. That it should be continuous, basically. The second equation, SAB, is the energy momentum tensor that the brain should have, okay, in order for everything to be a solution to the Einstein equations. And this says that it's related to the jump in the extrinsic curvature. The extrinsic curvature, just to summarize, is how this brain is embedded into this higher dimensional picture. As you may understand, I mean, the brain is is a D3 brain. We have a 5-dimensional space, so there is a codimension one going radially, or through the ADS throat. Okay. If we assume, for example, that the brain is static, it's fixed at some specific radius of the ADS throat, and then there is nothing on top, so it's just a pure brain, then the tension of such a brain will be given by the difference of scales between the inside and the outside. Okay, but as we were explaining before, we know that we have this stack of D3 brains. Then one brain can nucleate, escape from the horizon of the 5-dimensional Rising-Nordstrom identification, and then start expanding. Then we have to compute what the junction conditions are when the brain is moving. If we do that, the first line already should be familiar to you, and is a Freeman-Robinson-Walker expanding cosmology. And the second line, if we assume that there is only tension on top of the brain, so the brain is pure, then the tension is given, the second Israel junction condition is given in this way, by the difference of the square root of the scales and how this brain is expanding along the radial direction. The point is that this is, let's say, purely geometrical, purely mathematical. I mean, the nucleation of the brain itself is a Coleman-de-Lucia instanton. So for the Coleman-de-Lucia instanton to somehow expand, the tension, or the bound should not be shouldn't be extremized. It should be a little bit subcritical. So this translates into having the tension of the brain to be subcritical. So if we take this expression and then we study what happens at a regime that is, you have subcriticality of the tension, you can rearrange the whole equation into this Freeman-like equation. And then you have to identify things coming from 5D to the things that you want to interpret in 4D. So for example, the dark energy density will correspond to the difference between the critical tension and the tension that the brain have. And recall that it's subcritical, so it will be something really small but positive. While the Newton's constant in 4D is no more than the Newton's constant in 5D related to the difference between the ADS scales that you have into the game. So just rewrite this, then you get the familiar Freeman equation of an expanding an expanding cosmology. And then basically what you are doing, what we are saying with this, is that the Israel junction conditions provide a way to understand how this setup can induce dark energy on top of such a bubble, and is no more than a dynamical property of a higher dimensional picture. So we already crossed this border, the junction condition border, that will give us new technology, will give us new information on how to continue deriving the scales of the game. So we had the Newton's constant related to the number of brains, the ADS-CFT dictionary, and now we have two new equations. The first one, the critical value of the tension, the critical value of the tension, and then how to relate 4D and 5D Newton's constant. We can start playing with this, and then using these four equations, we can arrive to, for example, if I impose that the Newton's constant across, the Newton's constant remains constant, that implies that the flux number between the inside and the outside has varied. There will be a difference of 1, and that will imply also that there should be a difference on the scale. I mean, the radius of curvature between the inside of and the outside of both non-supersymmetric ADS vacua. If I impose that, I get this relation, and then using both of them, I can rewrite the tension of the brane to be this value. So delta n is just the difference between the difference that one would observe between the inside and outside respect to the number of branes. If we assume the nucleation of just such a brane, this is -1. So we prove that the tension, the critical value of the tension corresponds to the fundamental tension of a D3 brane. So that means that the tension that the brane that has nucleated is critical. This basically points to the fact that, at least from this construction, from 10D, at leading order, we will not get a positive cosmological constant. Nothing to worry. I will talk about this later. Let us now focus on what happens to the relation between G4 and G5. So we do exactly the same game. We put it inside, play it a little bit around, and then we observe that G4 is n times G5. This basically means that gravity is stronger in the 4D than in the fifth direction, okay, in the compact dimensions. So this already will give us an inversion of the scales that we are used to from regular compactifications. Because with this, we can rewrite all the scales that we had before in terms of the number of branes we have into the game. That, of course, in order for it to work, the ADCFT dictionary to work, n should be a really, really big value. Okay, I will fix that value later. But then we have the whole scale hierarchy given by the number of branes. And then, as you can observe, L4 is bigger than L5, which is something completely different to regular compactifications. So back to the thermometer that I saw before, it's something like this. And then now, let me talk about the problem of the cosmological constant, because as I was saying, the leading order, we get critical tension, and this is a problem. This looks like a, okay, if this was an excursion, this would be a flat tire of the bus we are in, so we have to start hitchhiking for like someone to pick up and take us to our destination. And in this case, will be alpha prime corrections. So the point is that, well, in order to summarize, there should be expected corrections due to the heightening of the branes escaping from the horizon, from the stack of branes. So those corrections will be as 1 over n. Okay, will be given as 1 over n, where n, recall, is the number of branes you have into the stack. Then here there are two types of corrections, and the ones that I want to focus on are like corrections to the DBI action. Sorry, not only to the DBI, but also to the West-Sumino piece of the brane. So these corrections, what they will do is to decrease just a little bit the tension of the brane, such that now, after considering them, we get a subcritical tension. Hence, we can induce a positive cosmological constant on top of the bubble. Schematically, the action accounting for the alpha prime square corrections to the DBI and the West-Sumino piece looks like this. You can start playing with all the terms and so on and so forth. And then at the end of the day, you get that now the tension will be the critical one multiplied 1 minus this alpha prime divided by L correction. As you can already see here, we just take this value with the ADS-CFT dictionary, and then as expected, we get 1 minus 1 divided by the number of branes and the coupling, string coupling into the game. So this would be, so this term that you see here, this 1 minus 1 divided by m will be the value of the dark energy density. How can we fix it? Well, we just go outside, go to the data that we have from our cosmological observations, put it in, and then this tells us that the number of branes that you should have into the stack is more or less 10 to the 60. Actually, I was computing it this morning, and it's 10 to the 62. So you have that extra 2 there. That's what it doesn't change much because it's a really, really big number. Now that we have fixed n, the number of branes we have into the stack, we can go back to the scales and refix it again and find what kind of scales we have, numerical values, basically. If we do that, then we observe that the radius of curvature of the compact dimensions is 10 to the -5, so nothing really small. But we get scale separation. We get these new scales not by having small compact dimensions, but having a really subcritical tension or a ratio between the charge and the tension of the brain to be subcritical. Then we also get, as we were saying, that the number of the Planck length in 5D is way smaller than the Planck length in 4D, as contrary to what happens in regular compactifications. And maybe you do not recognize this 10 to the -20 meters, but if you translate that, so that will be the Planck length in 10D. If you translate that to electron volts, you get around an order of magnitude of like 10 tera electron volts, which is kind of close to what we can achieve right now in the collider, or at least in the new generation. So, I mean, this is maybe like, just take it with a grain of salt, because at the end of the day, well, there may be like extra corrections, but basically there can be like nice interactions, or we will be able to observe nice interactions if this is true in the following decades. So I already described how to get a positive cosmological constant using like technology from string theory, provided by supported by the weak gravity conjecture, on how the tension should be corrected somehow, and so on and so forth. But we do not want a de Sitter universe. We want to fill this universe with extra content. So what do we do with this? Well, as I said at the beginning, things happening in the bulk will induce or will affect the motion of the brain, and then will induce energy densities that we are aware of, or like we're really well known. For example, if you put mass into the bulk, so let's say a black hole, as I was describing before, you would induce immediately something that goes as an energy momentum tensor, or an energy density that goes as 1/8 to the power of 4. As we know, that corresponds to radiation. If, for example, also you put a cloud of like a semi-infinite strings attached to the brain, I mean, it's a brain, so it would have some strings attached to it and distribute homogeneously on top of such a brain, then what you will induce is dust matter. There is something problematic here, because the mass of those particles are close to the Planck mass in 4D, so it's not really dust as we observe regular matter, but something extremely heavy. So that's something to correct. But at least we know that strings with some properties will basically induce dust matter. If you, for example, put gravitational perturbations into the bulk, you have gravitational perturbations into the bulk, that immediately induce gravitational perturbations or gravitational radiation on top of the bubble. And the last thing we did is to study what happens if we put on top of the bubble. So sorry, the brain has an associated like gauge field, a field strength, FAB, that, well, it's on top of it. What happens? Then what we saw in the last paper, together with Ivano Basile and Suvendu Gire and my supervisor Ulf, we saw that this field will basically induce, will source a field strength H into the bulk. Okay, that somehow will correct the motion of the brain, inducing the right expected like energy momentum tensor that has to do with radiation in 4D. So let me go to discuss this a little bit more on detail. What happens when we get back reactive? So we have the brain is expanding, and on top of it, we put, or the brain has associated a gauge field that corresponds to like putting some electric field or electromagnetism on top of it. Then what we observe in what we did in the paper is basically that at the very moment you put that, this will act as a source for a field strength in the bulk, an H field strength into the bulk. These basically, I mean, if you, for example, you forget about this field strength in the bulk, and then you want to compute the energy momentum tensor that you will induce on the brain when this field, this 4-dimensional field is on top of it, there is a gauge choice that basically will tell you that it will contribute. You will basically see that the energy momentum tensor that you induce on the brain has the opposite, so the Brown and the Brown sign. So it will contribute with a minus instead of a plus. You will have a negative energy density, and that's problematic. That's only problematic if you do not account for what is going on in the bulk, because at the end of the day, you now have a field strength H into the bulk, and then the bulk will know about it, and we will back react. So, and the back reaction will be in such a way that the presence of this field strength will somehow pull from the brain in such a way that will give rise to the right energy momentum tensor or the right energy density. So basically, when you do all of this computation that can be studied using the Gauss-Codazzi equations, which basically is like Gauss-Codazzi would translate into like put something into the bulk, assimilate it through like writing down what the line invariant or the new metric, the back reactive metric looks like, and then check how that gravity side, that differential geometry space, that geometry projects down to 4D. Whenever you study that, you will see two contributions that comes from the back reactive piece into the energy momentum tensor that you want to induce. One is the extrinsic curvature that will have a positive value, and the other one is the energy momentum tensor that you put on top of the bubble that will contribute with a negative sign. So basically, the extrinsic curvature will correct this problem and will always yield a positive energy density. This was done for electromagnetism, but can also be done for what we did previously for gravitational waves. The game is exactly the same. So just to summarize, what happens with the Gauss-Codazzi equations is that gravity is aware of everything. And at the very moment you account for any change in gravity in the bulk, this will also affect things happening in 4D and the energy momentum tensor that you can induce. So we are close to finish. And then just let me summarize quick what we did. So at the beginning, we went into the bus and we started from supergravity, going all the way down to 5D, everything boring, nothing new, just rephrasing a little bit things in terms of the number of brains we have into the game and just that. Then at 5D, we know that the brain nucleates, separating between an inside and outside for the vacuum itself, for the non-supersymmetric anti-de Sitter vacua. And then the junction conditions told us, okay, this is what how things work, having this construction. We proceeded with all the information that we have from 10D, and then we found an inversion of the, two familiar like scales, L5 and L4, but they are inverted in such a way that we get a new scale hierarchy, contrary to what we get in regular compactifications. But this came with a price that at least in order, we saw that the positive cosmological constant that we can induce, at least in this model from string theory, was already 0. So we have to account for someone to, help us. And in this case, what will contribute with some extra corrections will be alpha prime corrections to the brain action that will lift the cosmological to something really, really, really small but positive. And then finally, we put, apart from accounting for the cosmological constant and these corrections, we studied a little bit more how to, if you put things into the bulk, what happens to the brain. We commented a little bit about the Brown sign that may appear, but at the end of the day, this is corrected at the very moment you account for the back reaction. And then the back reaction will basically do that the bulk will lift the brain up, providing the right energy momentum tensor that you will induce on top of the brain. Just quick, some things that to do in the future, some future trips to do, is that, soon there will be an alpha prime. So all of this discussion about alpha prime corrections will become a paper that we hope to publish quite soon. Then all the thing to study would be like, okay, now that we know how to embed, how to put electromagnetism into the game, what happens, for example, if we look at electroweak interaction? So instead of one brain expanding in the radial direction of ADS, we have several branes at the same position, but at different positions in the compact dimensions, because the branes are localized in the compact dimensions. Well, then there will be strings between those branes in between those branes stretching between the compact dimensions, and that will give rise to some particles that may correspond to the electroweak process if you have the electroweak force if you have two of those branes. And then finally, this is something that I would like to study, and it's basically that everything that I have described is like for late time cosmologies, when we have a dark energy dominated area. But what happens if we go back in time? Can this model also explain a little bit of, or maybe even offer alternatives to the inflation proposal? And that's something that at least I think it worth to look at. But I will stop now. I think that I already took 25 minutes. So thank you so much for your attention.
Thank you very much, Daniel. Other questions? So maybe I can start with one question. Can you comment a bit more on 10 to the 60 branes that you need? So why can you say it again, why you need 10 to the 60, and how can you like expand on this?
Yes, so 10 to the 60
it seems a lot, right?
Yes,
I mean, it
indeed,
can be problematic.
Yes, I think it could be problematic, but the point is that whenever you account for like of course the alpha prime corrections, as you see here in the tension, this will transform and you will get a contribution that goes with the minus sign as expected, because we want to reduce the tension. I mean, we expect that from the weak gravity conjecture. So we get a contribution that goes as alpha prime divided by L4. Okay, this L4 comes from the extrinsic curvature. I mean, the dBi piece will have quadratic pieces in the Ricci tensor. Okay, different combinations of the Ricci tensor that will go quadratic. That will out something that goes as the trace to the power of 4 of the extrinsic curvature. And the extrinsic curvature, if you have just a pure brane, is no more than the curvature radius of the compact dimensions to the power of 4. Okay, then from there you just use ADS-CFT. Okay, you just use the dictionary that relates the radius to the number of branes you have into the game, and you can rewrite the dark energy density. Okay, because recall that the tension of the brane, when it's, I mean, the dark energy density is the critical tension of the brane minus the tension of the brane when the brane is expanding. Okay, that is subcritical. And the subcritical value is given by this tension, more or less tension, times 1 minus the correction. The correction is the dark energy, and it goes as 1 over n. And then we know how the dark energy looks like when we observe things. We take data from outside. In this case, I did it with the horizon, but if you do it with the dark energy, you start playing with the constants. You can get rid of everything, and then at the end of the day, the dark energy will be given in terms of the number of branes. So if you know the dark energy density, you know the number of branes. I did that this morning, and it goes as 10 to the 60 times the coupling, the string coupling to the square root. Okay, so of course it's a big value, but it's the model itself is giving you some technology such that you can connect everything derived from the 10D picture all the way down to 4D to make connections to what you see in the basically the dark energy density that you observe. So of course this is a toy model, okay?
Yeah.
So maybe there will be corrections in the future that maybe the number of branes is smaller. So
okay, thank you. We have a question, Michael.
Yes, that raises an interesting point. So you mentioned about the connection with inflation, potentially looking at the future. But if you wanted a large vacuum energy, like to have inflating, then you wouldn't have to need so many NC. NC could be of order 1, and you get a large vacuum energy that would inflate. And then the question is, does the number of branes, is that conserved? Or is that something like, they used to say you would have like a staircase where you could, lower these flux quanta and things like that?
Well, I mean, okay. So if the number of branes is conserved, you will have the stack, and then what will happen somehow, at least in this construction, what we looked at is like what happens is if just a single brain escapes from the stack, okay, due to the instabilities that you have directly into the 10D construction, is a really high chemical potential that will point to some instabilities that some of the brains can escape the horizon and then nucleate and start expanding. So this model already was on for like just one brain escaping. Okay, so of course the number of brains you have into the stack will vary just 10 to the 60 minus 1. Is something really, really small. But so far, I mean, here I'm talking to a little bit without knowing much, but I wouldn't say that that the number of brains will get drastically reduced. Of course, you can have things such as several brains, nucleates at the same time, then you will have some brains and strings attaching between them at different positions in the compact dimensions, and that will give you different SUN groups that can somehow help you to construct electroweak interaction or maybe even strong interactions. But the number of brains of the stack, as it is so big in this construction, I wouldn't say that for inflation, something makes them decrease too much. So when I say inflation, is like maybe to propose alternatives that can give more or less the same solutions as inflation, but without going into inflation itself.
Okay, all right, thanks a lot.
Thank you. Are there other questions? Okay, if not, I think we can end here. Let's thank the speakers again.